Hi viewers, welcome to the class on probability statistics. In the last video, we have completed discrete probability distribution and probability distribution and a probability distribution function with a discrete and so on. Today we are going to discuss about the distribution function or cumulative distribution function, and number 2, what is the probability density function. Let's move on to our first step, that is distribution function or cumulative distribution function or simply distribution function. Here for the first one, consider a x of a random variable of this consisting some type of events which having x1, x2 and x3 so on up to xn, and these I am going to represent it as xi, where I is equal to 1, 2, 3 so on up to n. This is our experiments, and this is a capital X is going to be my random variable. Here we are having that distribution function. The function indicates that f is for function. Here if the probability of any one of the values of x1, x2, x3, x4 and up to xn, let us write like this: probability of x is equal to function of the x is called probability function, and in the last class we have discussed this one, or probability distribution. Here the x value is going to be differ from 0 to n, so that I am going to take the summation on both sides of these, such as summation of x is equal to 0 to n, x is equal to 0 to n, p of x is equal to summation of x is equal to 0 to n, f of x. This is denoted by capital F of x, capital F of x. This is called cumulative distribution function. Here simply what is going here, the probability of something x value is going to be equals to the function of the same value of x is called a probability function. If we add any summation to the probability of x and function of the x, then it is going to be cumulative. What is the cumulative here? The cumulative indicates that addition of all the items in the f of x or p of x. Let us take one example for this. Here capital F of x, here I am taking capital F, and the x value going to be 3 or any 5. Here the x value is 3, so that taking the summation like this, or the summation of a probability of x or summation of a function of x is going to be equal, so that summation of x is equal to 0 to 3, that is the value of x is equal to 3, that is n, or the maximum value is going to be taken here of f of x. And while removing the summation of this, I am going to write like this: f of 0, this is small f, and this is going to be capital F, f of 0 plus f of 1 plus f of 2 plus f of 3. This is going to my distribution function, or cumulative. The cumulative indicates the addition of the all the members in the function. Here f of 0 plus f of 1 plus f of 2 plus f of 3 is going to be my functions of the respective values of x. Here this can be also written in the form like this also. Summation x is equal to 0 to x f of x is equal to summation x is equal to 0 to x p of x is equal to capital F of x. This is our cumulative distribution function. And moving on to the second type, probability density function. It is very simple to say that. And moving on to the second one, probability density function. Here we are having that f of x. Here we are having small f of x and also capital F of x, which represents the small f of x, that is a distribution function, and this is also indicates that distribution function. Here probability density function is nothing but the derivative of capital F of x dy dx of capital F of x is equal to small f of x. Here in some questions they only give the distribution function and we have to write them in the probability density function. Here the density indicates that derivation of capital F of x, or if any question given that small f of x, take that values and substitute in the formula. If you have the distribution function, you have to derive the distribution function with respect to of x, and then you are going to write the value of f of x in the given formula. Here f of x is equal to d by dx of capital F of x. This is enough. And tomorrow we are going to discuss about the expectation, mean, variance and standard deviation of probability distribution. Thank you for watching this. Keep watching and share my videos with your friends and family members. Thank you.